In the name of Allah, the most gracious, the most merciful, praise be to Allah, and peace and blessings be upon the Messenger of Allah, our Master Muhammad, and upon his family and companions altogether. Now, after finishing the discussion about power system protection in general in the first episode and talking about voltage transformers in the second episode, we begin with a new episode, a new challenge, and practical information that will benefit you in the job market about current transformers, CT. CT marks the boundary between zones, defining the start and end of each zone, ensuring no area is unprotected in the electrical network. An unprotected area is called a dead zone, which can be eliminated by achieving overlap through CT location. In the 132.32.8 kV station, CTs are placed in the switchgear. The feeder protection CT is between the bus bar and circuit breaker, while the bus bar protection CT is after the circuit breaker. There are 3 power transformers, each feeding its section independently. A circuit breaker, called a bus section, is placed between every 2 sections. The sections are named Section A, Section B, and Section C, with circuit breakers named Bus Section 1 and Bus Section 2. To protect the bus bar in Section A, we connect all incoming and outgoing currents in parallel, following Kirchhoff's current law, which states that the sum of currents entering a point equals the sum of currents leaving. The total current is shown in the diagram. Between every 2 sections, a circuit breaker is placed, referred to as a bus section. So the first section is called Section A, the second section is called Section B, and the third section is called Section C. This circuit breaker is called bus section 1, and this circuit breaker is called bus section 2. To protect the bus bar in Section A, we combine the directions of all incoming and outgoing currents by connecting all the currents in parallel in accordance with Kirchhoff's current law. Currents in equal currents out. Total current, 1 incomer, 1 bus section, 2 outgoing. CT for bus A is right of bus 1 breaker, bus B is left. Bus 2, protection needs 5 CTs in parallel. 1 on the incomer, another on the bus section, and 2 on the outgoing. Also note that the CT for protecting bus section A is placed to the right of the bus section 1 circuit breaker, while CT for protecting bus section B is placed to its left. This is, as we mentioned before, to achieve the overlapping between bus bar section A protection and bus bar section B protection. Meanwhile, protecting bus bar section 2 requires connecting 5 CTs in parallel, as shown in the diagram. They are the ones, and CTs are on both sides of the circuit breaker with 2 outgoing. Stack breaker protection collects only incoming currents via the incomer and bus section CT. If current exceeds the set value, it trips all circuits. Bus bar protection collects both incoming and outgoing currents, while stack breaker focuses on incoming. Section A needs 2 CTs, 1 from the incomer, 1 from the... We note that the difference between the bus bar protection and the stack breaker protection is that the bus bar collects the incoming and outgoing currents, while the stack breaker protection collects the incoming currents only on the bus bar. We note that Section A needs only 2 CTs, 1 from the encoder and the other from the base section, and Section B needs 3 CTs, 1 from the encoder, 1 from base section 1, and the other from base section 2, and Section C is treated as so. Based on my knowledge of the protection scheme, which means the plan and method of protection used, I distribute the locations and connections of the CTs accordingly. We notice that using stack breaker protection saves a lot of CTs, making it less costly than using bus bar protection. It's called stack breaker because it trips if the feeder circuit breaker fails to trip, meaning it prevents operation when a fault occurs on the feeder. We have another example of connecting CTs for 380 or 400 kV stations, which use the 1.5 circuit breaker system, where 3 circuit breakers are installed for every 2 circuits, as if we have a half breaker for each circuit. Here, the circuit refers to the B. Normally, all 3 circuit breakers are closed under normal conditions, so 2 bus bars operate under normal conditions. Therefore, each one is considered a main bus bar, and there is no difference between them. The circuit breaker in the middle is called the tie circuit breaker. When a fault occurs on any line, both circuit breakers connected to it will trip. Note that the tie circuit breaker will trip if there's a fault on the transformer or overhead line. However, if there's a fault on the bus tie circuit breaker, all 3 must trip. This setup allows maintenance on any circuit breaker at any station bus without disconnecting loads. Similarly, any bus bar can be disconnected without affecting any bus. This is why it's called the PN1 or North 1 configuration. It allows equipment removal without impacting the rest of the bus, stabilizing the network and ensuring continuity. Due to its high cost, it's used only in extra high voltage networks because of its critical importance. North 1 configuration. This means you can remove any equipment without affecting the rest of the bus, which helps stabilize the network and ensure operational continuity. Due to its high cost, it's only used in extra high voltage networks because of its critical importance. Thanks. Understanding the purpose, we aim to distribute CTs for optimal protection. CTs for busbar 1A and 1B should be placed after the circuit breaker, not directly after the busbars. Each busbar has 2 circuit breakers, so we place 2 CTs for each, considering both or at least one breaker could be closed. We can connect the 2 CTs in parallel before the relay or separately and combine them in the relay via software. Some stations use 1 CT, creating an unprotected T-shaped area, a dead zone. We provide T protection by placing 3 CTs connected to a differential relay. Per Kirchhoff's law, currents entering and leaving the busbar must balance. TID marks the start of the path to the line. We combine the 2 CTs before they enter the relay by connecting them in parallel. Or we can connect each CT to the relay separately and combine them inside the relay through software configuration. I also found in some stations that they only place 1 CT here to protect the line. So we end up with an area shaped like a T that is unprotected, known as a dead zone. We provide special protection for it called T protection or TID protection. We place 3 CTs as shown in the diagram and connect them to a differential relay. According to Kirchhoff's law, the sum of the currents entering the busbar must equal the sum of the currents leaving it. Here, TID means the beginning of the path, which is the start of the path leading to the line.